In section 2.2b, we will look at biconditional statements and Venn diagrams. Our objectives. I will know when to use and be able to write a biconditional statement. I will be able to interpret Venn diagrams and use them to represent set relationships, such as intersection and union. I will recognize and use symbols of formal logic. Let's begin by discussing the truth value of this statement. If yesterday was Sunday, then today is Monday. This is a true statement. Remember last time we talked about different ways to write a statement. What if we turned this around and wrote the converse? How does the converse work? If, starting with the conclusion, today is Monday, and then we end with what was at the beginning, the hypothesis. Then yesterday was Sunday. Considering the truth value of this statement, if today is Monday, then yesterday was Sunday, that is also true. When a statement is true forwards and backwards, the conditional and the converse are true, then a faster way to write it is the biconditional. Bi, a prefix meaning two. It works two ways. So we say yesterday was Sunday if and only if today is Monday. Here are two ways to write it. Yesterday was Sunday if and only if today is Monday. Yesterday was Sunday if and only if today is Monday. This is just a way to shortcut write if and only if. But when you see that connection in there, it means it's a statement that works both ways. We can say it if yesterday was Sunday, then today is Monday, or if today is Monday, then yesterday was Sunday. So 3 important things to remember about a statement. 1, it's a statement that is true both ways. The conditional and the converse are true. Second, the format, the way it is written, goes hypothesis, or a statement that usually starts at the beginning, the words if and only if, unless we're using the abbreviated version for if and only if, which is IFF, and then the conclusion, or the statement that usually comes at the end, such as yesterday was Sunday, if and only if today is Monday. The symbolic notation is with a double arrow because it doesn't just flow forwards to front to end, it flows both ways. It is true both ways. Let's take a look at an example. Write the converse of the statement. If the conditional statement and the converse are true, construct the biconditional statement. Then translate each statement into symbolic form using your own letters. 1. Conditional. If the sides of a triangle are congruent, then the triangle is equilateral. First, we are to write the converse of the statement. Remember, that means switch the order. So looking at the hypothesis and looking at the conclusion, the converse begins with that conclusion. If the triangle is equilateral. Notice sometimes I'll use symbols or abbreviations that are commonly accepted. If the triangle is equilateral, then, now I look at what was at the beginning, the sides of the triangle are congruent. Again, notice a commonly used symbol for congruent is the congruent symbol, so that's accepted. What's next? If the conditional statement and the converse are true, construct the biconditional statement. So let's look at the conditional statement. If the sides of a triangle are congruent, then the triangle is equilateral. This is the definition of an equilateral triangle. So this is a true statement. The converse, if the triangle is equilateral, then the sides of the triangle are congruent. Well, because we gave a definition, it will be true no matter how we write it. So this statement also true. If the conditional statement and the converse are true, we can construct the biconditional statement. So now we're going to do that. Remember, we take off the if and the then, and we connect the hypothesis to the conclusion with the words if and only if. So we begin, the sides of a triangle are congruent, and then we put those words if and only if, or feeling free to use the abbreviation IFF, then the triangle is equilateral. Not using then, not using if, because that implies it only goes one way. Now let's pick our own letters to translate the statement into symbolic form. The sides of a triangle are congruent. Maybe we'll call that A. The triangle is equilateral. Maybe we call that B. So the conditional statement, usually in alphabetical order, A arrow B. Remember, converse turns it around, B arrow A, and biconditional goes both ways. Now, since it goes both ways, it doesn't really matter which letter we begin with. However, because I begin with the sides of a triangle are congruent, and that's the A statement, we do need to follow since we're translating that order. So double arrow and then B. Now it's your turn. Can you try to construct a conditional statement that is true both ways, such that it's true as a conditional statement and the converse is also true? If you can, then you can write the converse and then the biconditional and the symbolic notation like we did in the other one. Why don't you pause the video, give it a shot, and see how you did. Now I'm going to give you an example of a conditional statement. I don't want you to use mine, but you can use it to try to think of something similar. For example, if 2 equals x, then x equals 2. So if you're having trouble coming up with your own conditional statement, use mine as a model and write something similar. Try to be as creative as you can to come up with something that is true both ways. Now, if it's true both ways, you might want to write something that is a definition. Those are always true both ways. Let's use mine as an example. If 2 equals x, then x equals 2. The converse, if x equals 2, then 2 equals x. You turned it around. It's true both ways, so we write the conditional. 2 equals x, if and only if x equals 2. Again, true both ways. Now I'm going to choose letters to do symbolic notation. The beginning I'm going to call W, and the end I'm going to call Z. So my symbolic notation goes W then Z, the converse gets flipped around, and the biconditional has the double arrow. Just make sure that if I call 2 equals x W and I put 2 equals x at the beginning, W goes at the beginning. Let's look at more symbolic notation that's going to be useful to us as we write arguments. Here are 3 that we've already been using. The single arrow, if then, P, if P then Q, the double arrow for if and only if, and the squiggly for not. Some more that we will use is that symbol I call the caret, or it looks like you're beginning to write an A for and. Upside down is an or. In fact, I kind of think it looks like drawing an R, like you draw that for or. And then the 3 dots in the shape of a triangle is how we usually conclude an argument, therefore. Let's practice translating statements into symbolic form. Let P represent the statement a quadrilateral has 4 sides. Let Q represent a rhombus is equilateral. R represents a rhombus has 4 sides, and S represents the statement a rectangle is a quadrilateral. Beginning with a rhombus has 4 sides. There's no if at the beginning of this, just a rhombus has 4 sides. Which of the letters is that statement? There it is, a rhombus has 4 sides, so that's the letter R. We'll begin our statement with R. Then I see and is the pointy one like we're going to draw an A. Then we go to a rhombus is a quadrilateral. Looking up here, a rhombus is a quadrilateral is what Q represents. So R and Q is that symbolic translation. Let's look at one that has a little bit more involved in it. A quadrilateral has 4 sides and a rhombus has 4 sides. Therefore, a rhombus is a quadrilateral. So beginning with, a quadrilateral has 4 sides. A quadrilateral has 4 sides, P. And a rhombus has 4 sides. And is like I'm drawing an A, but I don't slash it. Then it says a rhombus has 4 sides. A rhombus has 4 sides is the letter R. Therefore, that's the 3 dots in the shape of a triangle. Therefore, a rhombus is a quadrilateral. Now, because therefore is like we're concluding a statement, we really want it underneath that statement to say this is what follows. So we'll put dot, 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 and then a rhombus is a quadrilateral. A rhombus is a quadrilateral was the letter Q, like that. So remember, when it's therefore, it should come beneath it. Last one. If a rhombus is a quadrilateral or a rectangle is a quadrilateral, then a quadrilateral has 4 sides. I see if, then. So I know I'm going to be using the if, then arrow. I also see or, so I'm going to be using that V shape for the or. Let's see how to write that. A rhombus is a quadrilateral is the letter Q. Or is my symbol that looks like a V or like I'm starting to write an R. A rectangle is a quadrilateral, that was the last letter S. And because I have then, now I know I need to write my arrow. Now usually you're going to see those sectioned off with parentheses and then an arrow for then, and then the final letter. A quadrilateral has 4 sides, which is represented by the letter P. I agree. That's pretty fun.